it's Mrs. Elward this week, and today we are going to talk about proving parallelograms and rectangles using these coordinate proofs. So, in parallelograms, think about some of the more important properties. They look like this. And a parallel, well, apologize for my bad drawing, but the main idea of a parallelogram is that opposite sides are parallel to each other, even though I can't draw very well. So that's going to be the easiest way to go about proving a parallelogram. There's a few other methods. If you look it up on Google, you'll be able to um, prove parallelograms with opposite sides the same length because we know opposite sides are congruent. You could prove that the diagonals bisect each other with the same midpoints. That's totally okay too. But just for consistency's sake, it's just easiest to find all four slopes and show that opposite sides are parallel. Now we've talked about with the right triangles that if two sides make a right angle, then those slopes are going to be the opposite reciprocals. Now, in order for lines to be parallel, the slopes are going to be the same value. So our formula is going to be the slope formula. So whether you use rise over run, or y2 minus y1 over x2 minus x1. And a lot of times I tend to put the first point first and the second point second. That's just me. So you can do y1 minus y2 over x1 minus x2. It works the same exact way. So if you have the graph, you can simply do rise over run, which is what I'm going to do, but you can always use your formula. And what we're going to prove is that both pairs of opposite sides are parallel. Okay. My pen's dying, so I got to grab a new one for us. So our first example that we have here, we're going to graph quadrilateral lake. So let's plot those points. So L is at -5, -2. Make sure you label your points. A is at -3, 1. K is at 2, 0. And E is at 0, -3. If you have a straight edge, go ahead and use it. But if you can draw some nice straight lines, that's awesome too. So we're going to prove that lake is a parallelogram. So this is how I like to do it. Off of each side, I like to draw a right triangle. So I kind of do this little dashed right triangle. If you've had me in class when we've had to find the length of a line segment in previous units, especially talking about dilations and finding scale factors, comparing one side length to another, then we've done this. So I make my right triangles. And then off of that, I can find my rise over run for each side length. So I'm going to list out each of my sides and find their slopes. So I'm going to start with LA because L is my first letter. Okay, so I'm going to do LA. And LA is going up, so it's going to be a positive slope. So it's going up 1, 2, 3, and right 1, 2. So it has a slope of up 3 over 2, a rise of 3 and a run of 2. And then I'm just going to keep going around in a circle here. So A to K. And that's going down, so it's going to have a negative slope. And it's going down 1 and right 1, 2, 3, 4, 5. So it's going down, so negative, and it's going down 1 and right 5. All right, so then keep going, K to E. And that's if reading it from left to right. We always read left to right. That's going up. It's going to have a positive slope. And it has a rise of 1, 2, 3, and a run 1, 2. So a rise 3, run 2. Hey, right off the bat, those two slopes are equal. And then my last side, I'm going to keep going, E to L or LE. It doesn't really matter the order that you put the letters, okay? And that's going down as we go left to right on the graph. It's going down 1, so -1 over, and we count our boxes, 1, 2, 3, 4, 5. So down 1 over 5. And again, those slopes are the same value. So we have two pairs of opposite sides with the same slope, so they're going to be parallel to each other. So we do have to write a concluding sentence. So we're going to say, lake is a parallelogram because LA is parallel to KE and AK is parallel to EL. And that's all you have to write. A nice little concluding sentence about what you found. Let's try the next one. So it says, given points C, 1, 8. All right, so 1, 1, 2, 3, 4, 5, 6, 7, 8. There's C. A is at 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. There's A. M is at 2, 2. 1, 2, 1, 2. It says find point P so that camp is a parallelogram, and then prove that camp is a parallelogram. So it's really important that we connect the points in order. So it has to be C to A to M to P and then back to C again. So I'm going to connect them. C to A to M, and then where would P have to be? P would have to be somewhere over here so that it makes that full circle and looks like a parallelogram. So what we need to do is to find the slopes of these two sides, and then that can help us find our missing point over here. So I actually would probably, we can find them both and do that. So CA and MA. So I'm going to make my little right triangles. So let's start with CA. So it's going down from left to right. So I know it's going to be negative. And it's going down 1, 2, 3, 4, 5. And then it's going right 1, 2, 3, 4. So -5 over 4. And then MA going, or AM, either way, it's going up left to right. It's going up 1 and then right 1, 2, 3. So it's going to have a positive slope of 1/3. So I know that point P has to be over here somewhere. Now to make the least amount of errors possible, I'm going to go with the 1/3 because I have to count the least number of boxes. So I'm going to go backwards off of point C. I'm going to go back 1, 2, 3 and down 1. And there's going to be point P. But let's just check to make sure that that also follows our -5/4 rule. Can I go down 1, 2, 3, 4, 5 and over 4, 1, 2, 3, 4 to get to point M? Absolutely. So I found it in the right place. So we need to also show those slopes to show that it's going to be a parallelogram. So PC, we found point P by doing that slope of 1/3. And then we tested PM by doing that -5 over 4 to test to make sure it worked. So it's going to work. It also wants us to state what point P is. So point P is that's at -2. and then 1, 2, 3, 4, 5, 6, 7. Remember, when reading a point, it's always x comma y. It always gets confusing when you're dealing with slopes and then writing points, because slope is y over x, and then when you write a coordinate, it's x comma y. So just be careful how you're writing it. So then we got to write our concluding sentence saying that camp is a parallelogram. So camp is a parallelogram because, just like up above, we say which sides are parallel. Okay, so that CA is parallel to PM and MA is parallel to PC. And we're done with that one. So next we have to talk about rectangles. And rectangles are very similar to parallelograms, but I am using a different recording device than Mr. Lustica does. So I have to do videos in two parts because I upload to YouTube and I can only upload a maximum of 15 minutes at a time. And I'm afraid I'm going to go over that. So hold tight for right now. This is going to be part 1 of your notes for today. And then hop on over to the second part of the notes for the rectangle half of today's notes. All right, so just hold tight and jump over to the other half. Talk to you in just a second. Bye-bye.